Well, welcome back. So we have taken the last 20 problems in the recent Texas assessment of skills test. That's the state test called the STAAR, and 15 of the first 20. In 15 of the first 20, we have used the Desmos graphing calculator to assist us in solving the questions. That's 75%. Let us continue on, and we are going to move on to the next one. And so the next question asks us, which graph best represents y equals minus x squared plus 6x minus 1? Looks very straightforward. Looks like you could just enter that into the Desmos calculator. You can open up a new calculator document, testing calculator, and we put it right in there. And it's pretty straightforward, and it's in the quadratic equation format. And there's your zeros. And actually, it's simply asking us which one looks like the choices, A, B, C, or D. So it's simply a matter of entering the equation, the quadratic function, and looking to see which one matches. And we see that, in fact, it's quite straightforward. Yeah, well, it begins with a negative x, so that's the clue that the concave is going to go down, that the loop is going to be facing up, that the vertex is going to be on top, and so you can already eliminate two of these, and there's only two left. And carefully look, and in this case, the difficulty will be in discerning which point falls exactly where we need it to fall. So let's take a look, and in this one, we have the zeros occurring at, let's put the zeros. Zeros, I can make a note to myself. It's not going to calculate, you can see that. And if I want to zoom in, I can zoom in with my fingers. So I can use this right here to very carefully look at, it says 5.828, and I'll just, zeros are at 5 point, this is an exact number. I mean, it's a decimal, but I want to copy it exactly as I see it. And x is at 5.828. And my next one is at, let's see, I don't really have to zoom in. You can actually pretty much get right on there. And 0.172. Yeah, so they're both positive. 0.172, 0.172. Double check that. Okay. So if I look here at my choices, it's between these two because of the concave, but they're very close. And the day of the test, if you happen to still be taking a paper test, you might want to have a magnifying glass. I'm not sure it's a prohibited item, but you can ask. Okay, so if we're looking for something close to 6 and something close to 2, something close to 6 and something close to 2, okay, something close to 6 and something not even close to 1. So let's move on to the next one that appears. That's something close to 6 and something on the other side of 1. So we have a problem here that none of these is matching up. So let's find out why. So all of a sudden it's not as straightforward, is it? Okay. So let's see if, let's make sure we typed it correctly. All right. All right. Okay. Negative 6x squared plus 6x minus 1. Which one best represents minus 6x squared plus 6x minus 1? Okay. Let's write it again. Sometimes copying it introduces some kind of mistake. Minus 6x squared plus 6x minus 1. All right. So something just to the right of the 0 and something just to the left of the 6. That'd be a 5, okay? All right, so let's look at this. Something just to the left of the 6, right? Just to the right of the 0, to the right of the 0, and that's probably going to be close enough, right? Let's take a look at the runner-up. And this one, you can see that it's to the left of the 0. Remember, they're both positive, so this one is to the right of the 0, and they both seem to be, wait, okay, all right. Be careful. Oh yeah, positive. It's to the right of the 0. Sometimes your mind plays tricks on you depending on the way you look at it. Yeah, look at the y-axis. So this slant, this curving is in the positive territory, and this one is just to the left of the 6, and that appears to be what we have here. I am now more confident in choosing for number 21. I will choose A. Let's look at our answer. 21 is A. Good. Now, just a second here to talk about what these numbers are. In the state of Texas, if you happen to be taking this test, throughout the year, your teacher prepares you for certain standards. And the standards are labeled as such, and 8.7 might be student can perform quadratic equations with a certain number of variables in a certain number of, certain manner of appearance, something like that. So that's what these letters appear as. And I keep going through them simply because they're part of the answer sheet. Let us move on to the next one. Desmos definitely helped on that one. So we're off to a good start with the calculator. And for the next one, we see we have in front of us yet another table. So now you recall the last time we had a table about a couple of questions back. I was very cavalier about the X and the Y. Let's stick, and the last time it made a difference whether I chose X on the left, Y on the right. Let's keep it that way. And so let's make our table. Even before I've even read it, I'm already saying, you know what, I have time. Let me make the table. The illustration, the line, the curve, the parabola that it draws might be able to help me to answer the question. So I'm making that decision even before I've read the question. Now you say, hey, you know, I might not need to. Well, maybe you don't need to, but it's simply my suggestion. Now, I'm going to read it. A company advertises on a website. A worker tracks the number of visits to the website and the number of clicks on the advertisement. The table shows the data for several days. A linear function can be used to model the data. Model the data. A linear function can be used to model the data. That right there tells me that we're looking for an image, right? Model the data. Let's check it out. We open to a new graph and hit our plus sign, table, and from the left side, we have the number of visits at 153, 629, 471, 914, 307, 1045, 510, 6. On the right side, 14, 38, 30, 53, 21, 60, 32, 63. Oops, I must have missed something because they don't match up. 14, 38, 30, 53, 21, 60, 32, and 63. All right, I click on here, hold down, make a line, see if that gives us anything. Well, let's see. pattern there extends to 1106, our highest value, 153, our lowest value. And so we have that. And I suppose I should read the rest of the question, shouldn't I? Okay, let's see. Based on the table, what is the best prediction of the number of clicks on the advertisement if 1,500 people visit the website? All right, let's see. All right, so 1,500 is a number that is above 1,100. So 1,100 at 63, okay? A company advertises, I'm going to read again, see what notes I can make. A company advertises on a website and worker track the number of visits, all right? Visits to the website and the number of clicks. All right. The table shows data for several days. A linear function can be used to model the data. All right, let's say, what's the best prediction? Okay, well, let's see. So there is a number going up, clicks are going up. We have a change. So I guess it's, what I'm guessing, if I remember the other questions, is a change in the number of visits over the number of clicks. Change in Y over the change in X. All right. Okay, yeah. And I'm being kind of silly and careless here because there's no guessing with this table, is there? It tells you number of what visits to the website, X, number of visits to the number of clicks is Y, X and Y. So there's no disputing that. Okay, so try to be careful in reading these. All right, so let's see. So my change in Y, let's just take two figures. All right, let's go here and talk about the change in Y over the change in X. We remember that is actually in our chart if you forget it, but after several times of doing that, I remember that the change in Y, Y2, the formula is Y2 over, or take away Y1. And that is a fraction. Here we hit our division sign. Okay, here's our division sign. And that gives us a fraction, it's Y2 minus Y1. Okay. Over X2 minus X1. Okay, so that's just to note that that's what I'm looking for. So I look over here, and I'm just going to pick two values here. And I'm just going to pick the bottom values because they're the ones that are closer to my 1,500 figure. Okay, let's pick these two values. You know, maybe I can pick these two. No. This is give us a good change. Okay. Yeah, okay, just remember to mark that this is going to be your Y2 over your Y1. This is going to be your X2 over your X1. Let's go to town on that. Go to our Desmos and set up the fraction. And so we said that it's going to be Y2 63 minus 32. Okay. That's Y2 over Y1, 1106 over 510. Change in Y with the change in X. It gives us 0.052. Okay, and let's see what the fraction looks like. 31 over 596. 0.052. Y2 over Y1. y2 over y1, 63 over 32, 1106 minus x2, no, x2, 1106 over x1, okay? So what can we make from that number? 0.052. Let's go over here back to the choices. Okay, back to the choices. So, okay, right. So we have 4 choices and 4 choices. Okay, and they have to be plugged into this formula. So how do we set this up? We look at the first sets that we chose. 63 minus 32, y1 over y2. So 1106 over 510. And that gave us an answer of the change or the slope of 0.052. There's also a fraction of that, which doesn't really help us. 0.052, okay, so the rate is 0.052. So we have to get something from these numbers that gets us close to that same rate. We were to plug them in. So let's, I guess this is a trial and error one using the Desmos calculator. So let's see. Well, first of all, that's 0.052, but let's see if that's a consistent rate. So just to confirm that it's somewhere in that area of 0.052, let's take another set of numbers. Let's take 1,045. Let's make our fraction. 1,045. No, wait. Y2 first, right? So let's take 60 minus 21. 60 minus 21. That's another y2 over y1 change. 60 over 21, or minus 21, over x2 of 1,045 minus 307. 07. Okay. All right. And that is giving us a constant rate, 0.052. All right. So far we have 2 that are giving us that rate of 0.052. Okay. So whatever we get with the given numbers of 1,500 people, 1,500 people, those are X, 1,500 people. All right. So let's see, we need 1,500 people, it's our X. Yeah, okay. So, yeah. Let's let Desmos handle this. So we have a fraction, and it's 1,500 people minus some number, and it's 1,500, yeah, 50, well, that some number is 1106, isn't it? Yeah, 1106. Okay, that's 1,500 over 1106. Okay, that's the given. 1,500 over this next, what's the x1 value? That's the denominator. And our y value is some number, presumably one of these numbers. So let's try 77 over the next number, 77 over 63. Let's just try that. Again, we're going to go, okay, so this gives me a 0.035. Okay, that's quite a difference from what we've been getting. All right, so let's try, I'm going to copy and paste this and then change one value. And the one value I'm going to change is this one right here, because I'm going to take the next one, 137 over 63. and that gives us 0.18. So that's far away from our 0.05. Let's continue on. And pretty much the same number, but we're going to go down the list, and we've got 83. And I'm going to plug that in. And we get 0.05. Okay, 0.05. 0.05. Okay, so that's looking good. 0.050. These are 0.052. 0.052. Okay, so let's try the last one, see if we get a little closer. And the last one is 105. All right. 105. Okay. 0.10. Okay. So it seems that we're getting 83 is the one that gets us the closest. And if we were to put that in there, right? 83 and 1500, sort of just to confirm. Yeah, it's kind of, yeah. I guess if we put all of these points in there, it would give us something more disparate. But I mean, it's pretty much telling you. Now, could you do this without the calculator? Sure, but I like to visualize it. I like to visualize it. I like to see what we're talking about. Okay, and I want you to see it as well. I want you to see it as well. There we go. Back to the original, zoom out. And okay, so let's see if this works. Choosing 83 because that's the one that gives us the closest change in y over the change in x. That's number 22. Survey says H. Is that right? Is that 22? H. Okay. 83, right? H. Yeah. There we go. Thank you, Desmos. And again, could you have done this without the calculator? Sure. Yeah. But I prefer to, when we're doing this kind of mathematics, I mean, look at the divisions, fractions, negative numbers. Well, not negative numbers, but we have some subtraction, and we assure ourselves that we don't get messed up with negative numbers. And the xy and the x2, all of these fractions is just begging for you to use the graphing calculator or the calculator functions so that we keep the mathematics nice and neat, orderly, and we can refer back to it in one clean, well-structured, organized place. The graph of a linear function is shown on the grid. Graphing calculator. Can we use the Desmos? We certainly can. We're being asked for a graph. So this looks like it's about, yeah, it's standard slope formula because it looks like y equals mx plus b. Judge, based on a question I had in the past, I'd almost be tempted, let's see, copy these. All right, okay. I'd almost be tempted. Let's see, that's the first one. All right. Looking at them, I'm almost tempted to zoom a little bit higher. Almost be tempted to factor these out, but I recall a problem in the past where I actually did do this and it wound up being unnecessary because the graph is still plotted once you get the y by itself. Yeah, I think I went ahead of myself and kind of found out that if you just understand that this is still a permissible slope formula form, then I take 2 from both sides. Yeah, let's take 2 from both sides. All right. And it's subtract 2 from here and 2 from here. And that gives us the slope formula format. And that should be able to draw a grid based on the having done something similar in the past. So I'm going to go ahead and take 2 from both sides. Okay, notes to myself. And so that's y, leaves me y equals, right? So -2 and -2 cancel each other out. Okay, right? Let's see. Clear that. And so I'm left with this amount here. And I'm going to subtract 2 because that's what's left. And I get that kind of a graph. And I measure it to those that I have. So I'm looking for something that's positive slope, yeah. But I'm looking for something where the line falls in this, what they call quadrant, in this section of the graph. And that's not there yet. So let's continue. The next one, and it's, let's see this. Okay. -2, 7. Say, rewrite this. Same line, and the difference is it's plus. It's a -2, so this becomes a +2 on this side. So this time I have to add 2 to both sides, right? Just a little reminder to myself. So I add 2 to both sides. I add 2 to my -2, right? Add 2 to my -2. And that cancels that out. And so I'm left with a -2 on the other side. All right, so let's see. So I'm left with 7, 5, x -7 plus 2. All right. Okay, so I'm now on this side. And let's zoom into our graph and see that, okay, I'm in that quadrant. But look where the number falls. I'm somewhere at 4 and -3, somewhere there. Okay. I'm past 4, and I'm certainly past -3. We continue on. Okay, my next one says y plus 2, 5 sevenths, x plus 7, and it's a +2, right? It's a +2. So we'll get a -2 to cancel that out. Cancel that out with a -2 and put a -2 on the other side of that. Okay, so we're left with that. And so my dots don't match up. Let's try it again. And so we're left with it. We have a -2 on this side, so we're going to cancel that out by adding 2 and add 2 to this side and change the sign. Okay, I have that copied out, and I have to change the sign. And I've added 2. Okay, so, and that's actually 5 sevenths. Okay, what am I left with now? I got to zoom in. Let's turn these other ones off, turn them off, clicking on the side. Okay, and I'm near 4, a little beyond that, and I'm at -3, and that's appears to be the closest one, right? Yeah, and if you zoom in closer, you'll see that that's actually maybe a little beyond, but that's the closest one, so I'm going to choose my last one. That was D, okay? Our answer sheet for 23 is D. Yeah, D, right. And Desmos does it again. Okay. Yep, Desmos does it again. All you had to do is plug in the values, and you can see it was quite easy. Instead of factoring these out, it still understood the graph well enough to where you got the numbers just by bringing the 2 to the other side. Easy enough, right? Which expression is equivalent to xy to the -6 to the square, the power of 2, for all values of x and y where the expression is defined? Which expression is equivalent? It's equal to xy to the -6 squared for x and y where the expression is defined, Okay, so what I'm seeing is I'm not seeing a whole lot more other than, okay, looking at my answers, it seems all that is done to this one is that they've multiplied the exponents. And that appears to be all they've done. They've taken this expression and they've squared it, and that's kind of easy. And you don't need Desmos for this one, but we're going to use it anyway. Why? Because sometimes, depending on the level of comfort, even in a multiplication like that is a little tough for some of the students and sometimes confusing because of the negative sign. So let's use Desmos to do the basic math. Let's go here. So, okay, so here it is. It's an expression, 2 variables, x, y. It's raised to the power of -6. It's further raised to the power of 2. So all of that is raised to the power of 2. We multiply the outside exponent with each exponent that is carried on each variable. So in other words, whatever exponent x has, multiply that by what's outside of the parentheses. Whatever y is carrying as an exponent, multiply that by what's outside. So the trick for some of the students here, or the trip up for some of the students, is they don't see an exponent at x, and they think it doesn't have a power, it doesn't have an exponent. But please learn, or please remember, if you're new to algebra, a number that's not there is usually a 1. So in front of our x, we have a 1. It's 1x. There is actually a number. And so the same thing goes for exponents. When it's not there, when it's not an exponent there, then it is assumed to be, or it is the value of 1. That invisible 1 that is in front of the x is also an invisible exponent that is the exponent of 1. All right, so just remember that. So having done that, okay, and again, just because I have it, I'm going to use it. I'm going to say, I'm going to go here, and I know that my x has exponent of 1. And so 1 multiplied by 2, okay, oops, 1 multiplied by 2 equals 2. Right? Is that right? Yeah. So we have an exponent of, let's see. Okay, so my new expression is going to be, let's put it over here. All right, let's put it over here. X, y. So 2 times 1 is 2. All right? Okay, and so 2 times -6. Again, let's see, the, okay. Yeah, y has exponent -6. Okay, -6. So we multiply that -6. It's going to be multiplied by 2, and that's a -12. All right, it's a -12. So that's what our expression should look like. X to the square, y to the negative 12, x to the power of 2, y to the, okay. I see that H has that. And let's choose that one. And we'll chalk it up to Desmos keeping us clean on that one. And let's check our answer sheet. That is number 24. And H. Yeah, there you go. So we can say that Desmos helps us with that because, again, sometimes that can be a little tricky. Word problem. A college student completed some 9 courses worth 3 credits and some courses worth 4 credits. The student earned a total of 59 credits after completing 18 courses. A college student completed some courses worth 3 credits, some courses worth 4 credits. Credits 3, credits 4. Okay. That student earned 59 credits after completing 18 courses. How many courses were 3 credits did the student complete? That's one that takes me back to remembering that these are your 2 equations. You have 2 equations. The 2 equations, and you're going to solve for x. And then you're going to plug that x into your, let's see. You got 2 equations with the information you get. You're going to solve for x, and having solved for x, you plug that into the second formula. You've got one equation. Plug it in, then you solve for x, and with that solution, you throw it into the next equation, then you solve for y. And this is going to take a while till I formulate what's what. How many courses worth 3 credits did the student complete? Okay, I guess that's important. The student earned, okay, the college student completes, okay, where's my, okay, we have an X and a Y somewhere. This is where you better have some scratch pad because this is going to require some scratching of the head. X equals, what are my 2 variables? X equals credit course worth 3. X equals 3. And then we have a different value for y equals 4. Okay. So no, wait. Okay, I remember the sausage problem, and I started assigning values. Let's say that there's x equals credit. Okay. Let's say that the 3 credit courses, let's call them the, let's call them A. Okay, and then y equals the 4 credit courses. X equals. All right. Now let's see. All right. X equals. All right, I'm going to need some time with this, guys and gals. All right. Well, people, this is a situation where I actually had to reach out for a lifeline, and not some of my favorite questions. In fact, this is the most odious one that I can come up. This is one of the most odious ones that I can come across with. It it really requires patience and thinking. And when you get to question 25, this is right about the time you hope that you've gone to lunch, or you're ready to go to lunch, or maybe if you're going to lunch, if you're thinking, forget it, I'll just work on it after lunch. But I'll admit I had to reach for a lifeline on this one, and I have the humility to accept when I am so challenged that I just have to reach out. And of course, you won't do that on the day of the test. What I can say is that when you see something like this, it's, as I stated before, they're looking for you to solve for x in one equation, then plug that value of x into the second one. This is what I remember from doing these. Okay, and from, I'll tell you where I got some help from. Brainly, it was a brainly.com. You ask for help, and somebody's done something similar to this. And so let's start. Okay, so as I said before, x equals 3. Let's see, x equals 3. And then y, so y equals your, so I made some notes here. Y equals your 4 credit courses, right? So that's right. All right, so let's see. The student completed a total of 59 credits after completing 3 courses. There's another, okay, after completing 18 courses. 3 credit, the value of 3, and the value of y. The value of 3 and the value of y. Okay, so let's see. Okay, let's see. Value of 3 and the value of y. Let's try, okay, from what I remember, and I remember I got help for this. It's the value of, okay, all of the 3 credit courses. Okay, 3 credit courses and 4 credit courses, right? All right, equals 18. No, excuse me, x plus y. 3 credit courses and 4 credit courses. Clear, some courses were 3 credits, some were 4 credits. And so there's something missing there. And that's 18. Okay. So, all right. So let's see if this makes sense. All right. So we want to get x by itself, so we take away y. Cancel this out. X equals minus y plus 18, or 18 minus y. Let's say, cross that out. X equals 18 minus y. And those are kind of sloppy, so let's see. So x equals 18 minus y. Let's see if we're on the right track. I'll double check this. There's a chance I could get this wrong. There's just requires some thought. Okay, so x equals 18 minus y. Plug the 18 minus y in. What was the second equation? Now I got some help with the second equation, as I'll admit. The second equation was 59 credits is the value. 59 credits is the value. Okay. So what equals 59 credits? Let's see. Okay, the total number of credits is 59. Okay, so the total number of credits. So let's x plus y, x credits, x valued course set 3, and then y. So how many? All right, let's see. Okay. All right, so we have a value for x, right? Okay. This is really sloppy. Okay, value of all courses. Let me take this over here. Value of all courses is 59 credits. There are credits worth Y, and there are credits worth X. So X is 18 minus Y. No. How many credits? How many 3 credit courses does the student take? Okay, a 4 credit course. Okay, so the value. Okay, 4 credits. 4 credits times the 4 credit course. 3 credits times the 3 credit course. And again, this is me reaching out for help. 3 credits times the 3 credit course is 3 times X. But we have a value for X, and the value is X 18 minus Y. Okay, 18 minus Y. Plus the 4 times the Y value, which we don't have, equals 59. Okay. All right, so make note to myself, 3 times 18 minus Y. 3, okay, so that's the value of X. So courses are 3 times X minus Y. Courses. So the 3 credit courses, we'll call those courses A, are 3 credit courses multiplied by X minus Y, right? Courses B, which is the 4 credit course, are 4 credit courses multiplied by my value for 4 credit courses. It's Y, I think. So, and then we add both of them. We are adding our 3 times X, okay? 18 minus Y, what are you doing? 18 minus Y. Yeah, that's what, so we have it as X. X over here is very sloppy. I wish we had better pens. I might invest in a better pen kind of tool. But for now, okay. Okay. 3 plus 3, 18 minus Y, added to 4Y. Okay. And we can't do that on our testing calculator, and probably not on the usual calculator, but I'm just marking that out. 3 times X, 18 minus Y. Okay, all right. And so let's see. Okay, back to our values. 3 times 18, that's a big math right there, is 54. 54. 3 times 18 is 54, right? Let me make sure. 3 times, because 20, 40, 60, take away from 2 each is 54, but I just want to make sure because I don't want to do this in my head. 3 times 54 is 100, 3 times 18, right? 18. See what I mean? 3 times 18 is 50, 20, 40, 60, take away 2 from each, okay. All right, so that leaves us 54, right? Okay. All right, 3 times 18 is 54. Okay. 54 minus 3y, is it? So we have 3 times 54 minus 3y added to 4y, and that's going to equal 59. Okay, so, and I probably want to leave this up just for sure, just for being sure and double checking before. We're at 54 minus, no, 54, yeah, 54 3 times 18 is 54. We have minus 3y. 54 minus 3y. Okay. Plus 4y. Okay. That equals 59. Okay. 54. Let me see how sloppy it's getting. Okay. So we combine these two. 4y plus 3y is going to get us, yeah, I don't think we can do that right. 4y minus 3y. You see, it doesn't do it. But we can do it in our head, and that's going to be y, right? Y equals, okay, yeah, let's do that. Yeah, definitely you want to fast forward to this part. This is really not one of my better problems. 54 minus y. We now have 54 minus y equals 59. Okay. We now have 54 minus y equals 59. Take away 54 from each side. Cancels out the 54. Okay. Gives us a minus y equals 5. Does that make sense? No, we have plus y, 54 plus y. 54 plus y. Negative 3y. Yeah, that's a plus y. Okay. Plus y. 54 plus y equals 59. Take away 54 from each side. Y is equal to 5. And we're having to do this in our heads, actually, because calculator's not smart. And I can't, let me be fair. This is not supposed to be done on the calculator. I guess this is where they test your powers of actually figuring stuff out the old-fashioned way. But I mean, you know, for the 3 times 18, that's definitely useful because you don't want to, I don't want to be doing stuff like that in my head. It's just too easy to make a mistake. Y equals 5. So what? Now what? Okay. So y equals 5. So let's see, y equals 5. Y equals 5. All right. Okay. How many courses were 3 credits? Okay. So we said that the 3 credit courses were 4? No. 3 credit courses. How many courses were 3 credits did the student complete? Right. So how does that help us? Y equals 5. Okay. 3 credit. Okay, 3 credit courses. Now this is X, isn't it? X are the 3 credit courses. All right. All right. Let's see. All right. Back to my Desmos calculator and see what I've put up there. And we have here. Okay. This is our equation of our 3 credit courses and our 4 credit courses equal 18. That's actually over here. It's actually over here because x equals 18 minus y was where we got this from. Let's see, x, bring y to this side. Okay, x minus y equals 18. That's, wait a second. And we bring it over, we have to give it a plus. Okay, so make it a plus. Okay, so that's where we got this is from, right? Yeah, that's how we plug that in. Our x's and our y's equal 18 credit courses. Yeah, okay, so solve for y, we go back to our original equation of x plus y equals 18. Okay, let's go back. X plus y equals 18. Okay, and y equals 5. So x plus 5 equals 18 credit courses, 18 credits, 18 courses. These courses, 18. All right, the credits 50. Now we're done with that. All right, so let's get rid of that 5. Get x by itself. X are the 3 credit courses. 13. And x is 3 credit courses, and they total to 13. Okay, and this is just be another one where if I get it wrong, I get it wrong. Okay, but I did get help on it. 13. And so with all of the help that I got, which was again from brainly.com, was it? Brainly.com, I give them credit. I don't usually suggest that I want you to work it out anymore, but this was taking particularly too much time. And so let's see, that's 25. Okay, 25. Okay. Yeah. All right, there you go. All right, time for a break, I think. Yeah, not much help from Desmos in that one. Not much help. I did use it, but really this is the old-fashioned plugging in and getting the values, and sometimes calculator is just not much help. So we're just moving on. Let's get rid of all of this stuff here. And there you go. Whew. All right, a graph problem. Great. The graph of the linear function of f passes through the 0.19 slope of -3. What's the 0 of f? So go ahead and plot your points. And let's get rid of all of that. Okay, we just have to clear out that. And so let's look at point was -1, -9. Okay, we want to label it. We want to label it. There it is. And we want to do a comma and put the point on in the same box, because what that does is, well, we only have 1 point. Okay, we want 1 point. Well, that's a problem. What are we going to do at 1 point? I don't have a line, right? Okay. Well, the question is, what is the 0 of f? What is the 0 of f? So, oh, it's got a slope of -3. Okay. So y equals mx plus b. Okay. So y equals slope of -3 x plus b. Okay, so there are no sliders. There's no sliders. Okay, so the graph of the linear function f passes through 1, -9, and has a slope of -3. Okay, well, we have these values here, and let's plug them in. Okay, what is the zero of f? That's a tough one. You have to remember what the zero of the function and what the zero of y. Are they asking for the y-intercept? Well, I don't usually see it in that format. All right, so let's do this. We want this line to pass through here. So, and it has a slope of -3, downward slope. And so are they asking about the b's? Okay, so let's try this. All right, let's try, what's my points? Let's try listing all of our points, right? Let's go to our points over here. Okay, that's first one is 2. So okay, passes through. So our line has to go through this dot. This coordinate has to have that -3. We're going to leave that -3x, and we're going to start with 2. Okay, so that's our 2. So doesn't pass through it. Okay, go on to the next one. We have a value of 4. Okay, does not go through the point. Continuing on. Okay. All right. So let's, which is it 4? What was the next? What was the other value? Right. -6 and -2. Okay. So the next one is, okay, px -6. Okay, good. That runs through it. All right. And just to make sure, so, okay, so that should be it, but let's just make sure that last one is -2. Okay, -2, -2. Uh-oh, okay, hold on. Doesn't run through it. So it's negative, okay, so -6, -6. Okay, all right, -6, -6. Okay, okay, but it's a 0. They're asking for the 0, right? Okay, so I've got a -6. Okay, and it runs through it. Okay. All right. Okay. Okay. All right. This is 1-9, and the question is asking, what is the 0 of f? That means it has to be something that when we talk about zeros, it has to touch the x-axis. So it's touching the x-axis at -2. So, but the question is, it's touching the 0 at -2. Okay. Touches the 0 at -2. This is going to be tricky. All right. I got a -6 that I plugged in, and it touches the x-axis, the 0. Remember when you do your parabolas, you get your zeros, your positive and your negative. It's touching that line. So I'm tempted to put -6. but it touches my 0 at -2, 0. It touches my x-intercept. That's what's meant by the zeros, right? So -2. Yeah, -2. Yeah, it hits that x-axis. It runs through that point, and see, I keep wanting to take -6, but actually it hits that at -2. All right, and this is just a trial and error, and I think there's probably a better way to go about that, because I'm not sure that definitely your teacher's not going to teach you to trial and error all the way down, particularly if you don't have sliders, but that seems to work. Okay, all right, let's try that. -6, it hits the 0 at -2, hits that x-axis at -2. So let's choose J. All right. Okay. 26. That's 26. Okay. J. Yeah. J. And I was kind of half guessing it. I was kind of worried because that was partially a guess, and I've seen this question before, and it's a question of doing it over and over again, because I'm pretty sure that the last time I did this, I got one, and I chose the y-intercept. That's what I did. Yeah, because I said, oh, 0, -6, and that's the one that's going to know. It's the zeros are where it hits the x-intercept, and definitely use Desmos on that one. And if there should be a way for you not to have to use Desmos, but right now that's what I've got. Trial and error, plugging in the numbers. What is the value of the y-intercept of the graph? We have a graph of h of x equals 29 multiplied by 5.2 to the x. No choices. Okay, let's try to graph that. Let's copy it. Copy up until there. And okay. And I do not like that. Okay. Okay. And this is raised to the power of x, exponent function. We'll have an x there. We get a nice nice shape there. Okay. Zoom in, zoom in, zoom in. Look at my 29, look at my 29. Okay. And the question is, what is the value of the y-intercept? What is the value of the y-intercept? What is the value of the y equals 29 times 5.2x? Okay, again, having seen something like this before, and my impulse was to multiply these out for some reason, and multiply them out, and I'm thinking, hey, there's not a whole lot I can do. I'm not exactly getting anything from the x. So the x is there just to make this shape here. And so the value that we do get is 29. And from what I would recall to students is to remember the value in front of this operation. To remember that number in front of the operation, and you'll be fine. And that number is 29. Yeah. So function of x, or function of a number, equals that number multiplied by that figure raised to an x. If you see this again, look, remember the number in front of the 5.2. Remember the number in front of whatever's in these parentheses raised to the x, because you might see it again in this format. So it says bubble in 29 Okay, and I think the last time I was tempted to put the whole figure in, the value of the y-intercept, because y equals that. So depending on how your bubble sheet is set up, you may be pushed in the direction of either putting the 29, or some of you may be tempted to put in 29 multiplied by 5.2. And toss it out. It's a toss-up. Let's see a few more of these, but it's probably 29 or 29 point, but 29 multiplied by 5.2, not multiplied out. It's one of those two. Let's just move on with it. Answer key says 29. 29 only, the number in front of the parentheses. Okay, and Desmos did help us with that. Okay, at least to visualize it and say, look, it's going up my y-axis. And do you need Desmos? Well, just remember that number in front of the parentheses, but it may take on a different appearance next time. But that's the point at which the y is hitting that, and that's what it's asking. What is the value of the y-intercept? And what you can take away from that is the Desmos hits, allows you to see that line, that curve, it's got a special name, hits at just that point, 29. Yeah, and there it is in the 29 column, in the 29 coordinate. The graph of a quadratic function is shown on the grid. Quadratic function, there's the concave up. And I look for clues here, and I don't see, none of them have a negative to point down that we can eliminate. But it is in standard format. It is in standard format. And again, I caution you against, I just want you to replace that h of x. You can use it in Desmos, that's fine. I try to stay away from it. And y equals, let's see, y equals x squared minus 3x minus 9, x squared minus 3x minus 9. Okay, and let's see, so we have, I guess we should record, okay, that given the zeros of 6 and 0, 0. 6 and 0. So these are my zeros, right? Okay, that's where my graph should hit. Okay, I can actually make a note of that. Graph hits zeros at what appear to be positive 6 and 0. You can put the coordinate if you want, but those are my zeros. Okay, I'm not concerned too much with that one, but yeah, well, let's look at that. Hit zeros at 6 and 0. So just note 6 and 0. I put parentheses. I just want to mark it off that these are not calculating anything. Positive 6 and 0. Okay, so that's not it. Okay, all right, that's my given. All right, so we go on to the next equation, which is, all right, instead of negative 3x, it's going to be positive 3x. So I just copy and paste, and I'm going to make that into a positive, okay? All right, so let's see. All right, so let's see. So we said our zeros are at 6. That's not hitting it. That's not hitting it, and that's not hitting it. Let's do our next one. So x squared minus 6x. So we have x squared minus 6x, okay, minus 6x, okay, 6, 7, 8, 9, 10, 0. Okay, that looks good. 6, 0. My x is at 6. My x is at 0. Okay, and just to make sure, I have the vertex at 3, negative 9. Here I have the vertex at negative 9 and 3, and that looks to be about it. If you want to make sure, just rule out that last one. Rule out that last one if you just want to make sure. X squared plus 6x. All right, this is the same, except for that this is a positive. It's not hitting where we need it to go, but we knew that. We know that this is where it's hitting. That is well, this is going to be a long, drawn-out test. I think that's the one we took, right? All right, yeah. Okay, our answer is, that's 28. Okay, H. Thank you, Desmos. We did it again. Let's just move on to the next one because we're running out of steam here. 29. Which expression is equivalent to? Okay, looks like we have a nothing. It's actually not that difficult anymore, is it? Clear that. And I'm just going to take this expression, put it into Desmos, clear myself up here. Okay. And clean it up. 24x squared minus 22x. X squared, I square it by doing this, minus 22x. The last figure there is plus 5. Plus 5, okay? And that's what our operation looks like. Okay. So our operation has to match that. Okay. Okay. Let's move on, and we have this construction here. And you don't have to do anything fancy with it, really. It's copied right there. 12 plus 5, 2x plus 1. Okay, it's not matching. Turn that off. And x minus 5, x minus, that's pretty close, isn't it? Close, but no cigar, as they say. Let's see. Okay, because is it closely matching? Which is equivalent, so it's got to be equal, right? It's not, looks like it's not, best represents it's equivalent, which means it's equal. It's got to equal that. Turn that off. Let's go on to the next one. All right, and that's 12x minus 5. Look at that. Right? Perfect match. And do we need to do the last one? Probably not, but if you want to just make sure that the two of them don't come very close, no cigar. Okay. So that would be C, right? Over here. And this answer key. 9. Do that. Another one chalked up to Desmos. Let's just move on. Start finishing this off. We only have one more in this series. A system of equations is graphed on the grid. Okay. So which system of equations does graph represent? Okay, I think this is probably, you probably should be familiar and comfortable now with just plugging in the equations. Okay, so I have a pair of equations here, a pair of equations. All of them are it's standard format. Y is by itself, standard slope format, and we just have to have both lines represent both lines here. So let's go ahead and do that. Let's just start to enter these. So we have this pair here. Okay, and if you want to be clean about it, like pair number one. Pair one. Okay. Now it doesn't copy very well, does it? Minus x. Okay. Oops. Y equals minus x minus 4. Minus x minus 4. Okay. And 2x minus 2. I suppose if I wanted to, I could actually plot these points here just so that I can lay them on top of each other, but I just want to move on. Visually inspect that, and it's not hitting. Okay, we don't have a match. All right, moving on to the next pair, pair number 2. Pair 2 has x minus x plus 4. That looks like this one. Minus x plus 4. Okay. Okay. And 2x minus 4. Just copy this one. Okay. 2x minus 4. That's pair number 2. Okay. My cross is in this quadrant. My cross is not in that quadrant. Okay, let me turn these off. My cross is in this quadrant, and it's not matching. Looking for something in this quadrant. Okay, pair number 3. Going to be F, G, H. Okay, very close to what I have here. So I just copy, paste, get rid of that negative. Okay, it's already telling me that it's in that quadrant over there. I want to make sure. And minus 2x minus 2. Okay. And that's very close to this one, so I copy and paste minus 2x minus 2. Minus 2. Okay, let me turn these off. These did not match. It's not in that quadrant. We have one more to go. Let's turn these off. Okay, and so we x plus 4. Okay, copy that. This is pair 4. X plus 4. Look at that. It's already appearing in that quadrant. And it's the last one, so you really hope that this is it, or it should be it by default, right? But you don't know. I'm prone to making mistakes, particularly rushing through this, and as I am now. And the last line is at y equals minus 2x minus 4. It's very close to this one. I'm just going to copy and paste and put a minus sign in front of it. Okay, there it is at that quadrant. Okay, and it's crossing the x-axis at negative 4, 0. And negative 2, 0. So my zeros are negative 4 and let's see, zeros at, I don't know if it takes it. Zeros at the shift remote. Negative 4, negative 2. 2, negative 4. Zeros at negative 2 and negative 4. Okay. And this is going to have to work. Negative 2 and negative 4. And it's in that quadrant. And just want to make sure 4, negative 4. 4 and negative 4. And that's a match. So we choose that one, which is actually the last one right there. It's J. Okay. J right there. And our answer is, that's 30. And that is J. Correct. And Desmos makes that very clear. Very clear. So just going over the amount of times, or in this video, we did 10 problems. Most of them did deal with graphs, and the large majority of them did allow us to use the Desmos calculator, even in those that didn't have a graph. Doing the basic math with Desmos does help. Let's do the count. We have 1, which we certainly used the Desmos. We used the Desmos for this one to do the change in y with the change in x, which was a fraction, and we had that fraction several times to do the basic math, but also to do to assure us that the fraction was correct. We compared that to the graph that we did make with the table which we did do in Desmos. We certainly use, so it's 1. So we have 1, 2, 3, certainly use that, 3. We use this, we multiply these in Desmos. So we have 4. And we did not find Desmos useful for this one. So we had the count as 4. And in fact, let me just put this to the side. That was an excruciating one. You can just fast forward through it, of course. And so that's 4. 5, certainly, we have a graph. We definitely needed to see the 0 on that one. We did some trial and error there. And you definitely want to work on using more than trial and error, but Desmos did help. 5. And we did plug that into Desmos, make a graph of it. 6, definitely 7. And that definitely quadratic equation 8. Certainly 9. So 9 out of 10, 90%. So thus far, since that's 9 out of 10, and we have a 90% use of the Desmos calculator in this segment of the 10 videos. We had it previously had 75%. We had used 15 of the last 20. This now becomes 24 of the last 30. So that's quite a percentage, 24 of the last 30. And in fact, I could go to my Desmos and do the math, but you can go ahead and calculate for yourself. That's well more than half and more than 2/3. So very useful calculator. I encourage you to please, if you're a teacher, teach your students to use it, particularly as they may not have access to the TI Inspire at home. If they're allowed to take one, there's always the danger of misplacing it, losing it, having it stolen. Not to mention that the other calculators, including the TI, I don't want to beat up on the TI because it was very helpful for my students when I taught last year in an inclusion class, and the students who stuck to using the TI Inspire fared much better than if they had not used it. So, but the point being that this one is freely available on just about any platform. I encourage you to learn it, use it. If you're a teacher, teach your students to learn and use it and get good with it. See you on the next one.